Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video. In this video we are going to solve some more problems on differentiation. Okay. Our today's topic is differential. Actually differential and derivative or differentiation are relevant quite similar terms. However, their difference will also be investigated. So in this video, dear students, we are going to solve problem number 11 to problem number 18. That is to say, we are going to solve 8 problems, and our topic is differential. Okay, differential. Actually, for finding differential, we will first find dy by dx, and then we will keep dy on one side and shift dx on other side. Okay, so we will find our answer just in term of dy. Okay, so as usual, before start, find the differential of the function. Problem number 11, y equal to e raised to power 5x, and so on. Problem number 18, y equal to exponential function e raised to power x over 1 minus ex. Dear students, while solving these 8 problems, we will have to use following snapshots, which will provide us a basis regarding the solution of these problems. And we have dealt with these snapshots also previously, but not all. Some of these snapshots have been dealt with in our previous videos, so we will not discuss this snapshot in detail. Okay, however, this quotient rule formula will be applied in our these 8 problems. Okay, similarly, product rule, we no doubt we have dealt with these two this topic in our previous videos, but in these 8 problems, once again this formula of product rule and power rule will again be used. Okay, so we will not go in detail of these terms. It is sufficient if we show these snapshots on our screen. Then this is the new definition. Okay, we have not dealt with this topic in our previous video. This is our main topic, main term under consideration. Okay, definition of differentials. Okay, let fx represent a differentiable function. The differential of x denoted by dx is any non-zero real number. The differential of y denoted by dy is dy equal to f dash x dx. Actually, dear students, because we usually denote most commonly denote functions either by y or fx. Okay, so f dash x means f dash x is equal to dy by dx. So from here we will keep dy on one side and shift dx on other side. Okay, so this will be called differential. Okay, while derivative is in terms of dy by dx. Then again, definition of differentials, let y equal to fx represent a function that is differentiable on an open interval containing x. The differential of x denoted by dx is any non-zero real number. The differential of y denoted by dy is dy equal to f dash x into dx. We see there is a little difference between the wording of these two snapshots. Okay, now differential formulas. Let u and v be differentiable functions of x. Then constant multiple rule, d into cu will be equal to c into du. Because c is constant, so it must be written prior to d. Similarly, some are difference. Differential of u plus minus v is equal to du plus minus dv. Similarly, product duv is equal to u into dv plus v into du. Similarly, quotient d into u over v equal to v du minus u dv over v square. Yes, students, these 8 problems will be based on this example. Okay, in this example 5 problems have been solved. Okay, so we will use this technique in solving our 8 problems. Okay, students, when function is y equal to x square, then we know that its derivative, that is to say dy by dx is 2x. What is this? This is power rule. Okay, this is according to power rule, its derivative is dy by dx equal to 2x. Then differential will be, we will keep dy on one side and dx will be shifted on other side of equality, and we will get dy equal to 2x dx. Similarly, in example b, part b, y is equal to x square root or x under root. X square root or x under root is equivalently equal to x raised to power 1 by 2. So when y is equal to x raised to power 1 by 2, so here power rule will be applied and we will get dy by dx equal to 1 over 2x square root or x under root, because 1 by 2, which is power of x, will be written as a multiplying factor of x square or x under root, and then its power, which was previously 1 by 2, will be reduced by 1. That is, half minus 1 is equal to minus half, and we know that minus half in the numerator is equal to plus half in the denominator. So we can shift this power minus half as plus half, and this x will be shifted to denominator, and our answer will become dy by dx equal to 1 over 2 into x square root or x under root. From here, our differential will become dy equal to dx over 2 into x under root. Okay. Part C of this problem, y is equal to 2 sin x. Here 2 is a constant, and we know that derivative of trigonometric function sin x is cos x. So our dy by dx will become equal to 2 cos x, and because we are here going to find out differential, so dy will be equal to 2 into cos x into dx. Okay. Then part D of this set of examples, y is equal to x into cos x. Here product rule is, we are facing product rule, while for differentiating x cos x we will apply product rule here. Okay. In product rule, we know that one time we differentiate one of these functions and keep other function as constant, then with plus sign or addition sign we differentiate other function and keep other function which was previously differentiated as constant. So we can say that we treat alternatively. Okay, so we know that derivative of cos x with respect to x is minus sin x. So first time we keep x constant and differentiate cos x, so our answer will become minus x into sin x, plus we keep cos x as constant and differentiate x with respect to x, so its answer will be one unity, and when one unity is multiplied with cos x it will remain cos x. Okay, from here our differential dy will be equal to the same answer as in the previous step. However, dx which is in the denominator will be shifted to numerator and we will get our differential as dy equal to minus x sin x plus cos x into dx. Similarly, in part E of this set of problems, when y is equal to 1 over x, then we can write x as we can write y as y equal to x raised to power minus 1. Here x has power minus 1, that is to say x is in the denominator. So here while finding its derivative, power rule will be used and hence its dy by dx will be equal to minus 1 over x square, because dear students, x raised to power minus 1 is the original function, and here minus 1 will become as a multiplying factor of x raised to power minus 1, and then power of x, that is minus 1, will be reduced by one number, that is to say from minus 1 it will become minus 2, because minus 1 is equal to minus 2. So our dy by dx will become equal to minus 1 over x square, because x raised to power minus 2 in the numerator is equal or equivalent to x raised to power plus 2 in the denominator. So our dy by dx becomes equal to minus 1 over x square, and from here our differential dy will become equal to dy will be equal to minus dx over x square. Now this is our first problem number 11, where we are going to solve y equal to e raised to power 5x. We know that derivative of any exponential function is first time the exact exponential function is written as it is, no change. Then in the second step we differentiate power of e with respect to x. So y equal to e raised to power 5x implies that dy by dx will be equal to d over dx into e raised to power 5x, and this will be equal to one time this exponential function as it is, and then we will differentiate power of e with respect to x, that is here d over dx into 5x, and we know that here 5 from 5x, 5 is a constant, so it should be written prior to d over dx, but here we have not used this step, so we have directly solved two steps in a single step. Okay, so derivative of 5x will become simply 5, because differentiation of x with respect to x is unity or 1, and hence when 1 is multiplied with 5 it will remain 5, and hence our answer becomes equal to 5 into e raised to the power 5x. What is this? This is dy by dx, but we are going to find simply dy, differential. So This implies that dy will be equal to 5 into e raised to the power 5x into dx. Problem number 12, y is equal to 1 minus t raised to the power 4 square root or under root. Here once again, dear students, square root or under root is equivalent to or equal to power 1 by 2. So when we will differentiate y with respect to x, we will apply power rule. That is to say, this 1 by 2 will become as a multiplying factor of square root 1 minus t raised to the power 4. Then in the second step, we will have to differentiate 1 time 1, which will be 0 because 1 is a pure constant, and differentiation of t raised to the power 4 with respect to t will be 4 into t raised to power 3, and minus sign will remain as it is. So our dy by dt, because here y is a function of t, will be equal to half into 1 minus t raised to the power 4 into minus 1 by 2, then d over dt minus t raised to the power 4. Now we know that d over dt minus t raised to the power 4 will be 4. Suppose we take minus sign separate, t raised to the power 4 when differentiated, it will become 4 into t raised to the power 3. Okay, power rule. And this 4 in the next step, because 1 minus t raised to power 4 has its power minus 1 by 2. So this minus 1 by 2 can be converted into plus 1 by 2 by shifting this term from numerator to denominator. So and derivative of minus t raised to power 4 will be minus 4t raised to power 3. Okay, that is to say, power will become as a multiplying factor of t raised to power 4, and its power, that is 4, will be reduced by one number. So it will become 3 from 4, and this 4 here 4 is in the numerator while 2 is in the denominator, so we will get simply 2 in the numerator. So our dy by dt will become equal to minus 2t raised to power 3 over 1 minus t raised to the power 4 square root or under root. This is dy by dt, but we are going to find out differential, that is dy. So dy will be equal to minus 2t raised to power 3 over 1 minus t raised to the power 4 square root or under root into dt. Problem number 13, y is equal to 1 plus 2u over 1 plus 3u. Here y is a function of u. So we will differentiate y with respect to u. So dy by du will be equal to d over du 1 plus 2u over 1 plus 3u. Okay, dear students, here we can use quotient rule. But on the other hand, we have also an option to treat it as a product rule in place of quotient rule. Okay, its differentiation will be carried out using the formula of quotient rule. But if we convert this 1 plus 3u as power minus 1, then these two terms become as multiplying each other. So if we write this problem in this shape, then in place of quotient rule we will apply product rule. Okay, and we know that in product rule, one time we keep one function constant and differentiate other, and second time we differentiate other function and keep other function as a constant, vice versa. Okay, so yes, let's say this will become, first time we keep 1 plus 3u raised to power minus 1 as constant, and differentiate 1 plus 2u with respect to u, plus we keep 1 plus 2u as a constant and find derivative of 1 plus 3u raised to power minus 1 with respect to u. Here, dear students, here 2u, here dear students, 1 plus 3u because has power minus 1, so this minus 1 can be converted into power plus 1 by shifting it from numerator to denominator. Okay, and d over du, 1 plus du, it will give only answer 2. Okay, so 2 over 1 plus 3u, this is the answer of first part. Then plus 1 plus 2u will be remain as under, and 1 plus 3u raised to power minus 1, this minus 1 will become plus 1 by shifting it from numerator to denominator, and next step we have to differentiate 1 plus 3u with respect to u, so here answer will become 3. Okay, plus 3 into 1 plus 2, okay, here this is 1 plus 3u square, so we will take here 1 plus 3u whole square as a LCM, least common multiple, perhaps 1 plus 3u square. So this is because 1 plus 3u with power 1, so here 2 will be multiplied with 1 plus 3u raised to power 1 minus 3 minus 6u. What we have done here, we have simply multiplied this 3 with internal 2 terms. Okay, so here 2 into 1 plus 3u minus 3 minus 6u over 1 plus 3u square. After simplification, this step becomes 2 plus 6u minus 3 minus 6u. 6u will be cancelled with minus 6u, and 2 when subtracted from minus 3 will become minus 1. Okay, because minus 3 is a bigger term from this, when 2 is reduced it will remain minus 1. Okay, so our answer will become minus 1 over 1 plus 3u square. What is this? This is dy by du, but we have to find out differential in the shape of dy. So dy will be equal to the same quantity into du. Okay, so once again, dear students, here it is our discussion whether we apply quotient rule or product rule. Okay, so in place of quotient rule we have used power rule by reshaping the problem statement. Okay, problem number 14, y equal to theta square into sine 2 theta. Here once again product rule is under consideration because theta square is one function and sine 2 theta is another function. So dy by d theta will be equal to d over d theta into theta square sine 2 theta. In product rule, we know that one time we keep one of these functions as constant and differentiate other function, while with a plus addition, plus sign, we treat alternatively, reciprocally, we keep other function which was not kept constant in previous step as constant, and we differentiate other function which was not differentiated in previous step. Okay, so theta square into d over d theta sine 2 theta plus sine 2 theta into d over d theta square. This theta square will remain as it is. This sine, we know that derivative of sine is cos, so we will get cos 2 theta, but then we will have to find derivative of 2 theta with respect to theta, plus sine 2 theta will remain as it is, and we know that derivative of theta square with respect to theta is 2 theta according to power rule. Okay, so After simplification we will get 2 into theta square cos 2 theta plus 2 theta sin 2 theta. From here we keep 2 theta as constant and our answer becomes this, and this is equal to dy by d theta, but we have to find out differential dy. So dy will be the same quantity multiplied with d theta. Okay. Problem number 15, 1 over x square minus 3x. Okay. Dear students, here again we can use a quotient rule, but if we reshape our problem in this form, x square minus 3x raised to power minus 1, then we can apply power rule. Okay, here because here minus 1 is the power of x square minus 3x, so dy by dx will be equal to d over dx into this. Here minus 1 will become power of x square minus 2x, and power minus 1 will be further reduced by one number, so from minus 1 it will become minus 2. And in the second step we will differentiate the internal quantity within the power minus 2. Okay. These are two terms, so separately d over dx will apply on x square as well as minus 3x, and we know that derivative of x square will be 2x, while derivative of minus 3x will be simply minus 3. Okay, so 2x minus 3, this is the answer of d over dx x square minus 3x, and x square minus 3x raised to power minus 2 has been converted into power plus 2 by shifting it from numerator to denominator. Okay, so our dy by dx has become equal to minus 2x minus 3 over x square minus 3x square plus 2 power. Okay, but this is dy by dx, but we have to find differential, that is to say dy. So dy will be equal to the same quantity multiplied with dx. Problem number 16, y is equal to 1 plus cos theta. We know that cos theta square root or under root. We know that square root or under root is equal to or equivalent to power 1 by 2. So we rewrite this in the shape as this. So then, because y is a function of theta, so we will differentiate y with respect to theta. Dy by theta, d theta will be equal to d over d theta into 1 plus cos theta raised to power 1 by 2. Here power rule will be applied because half is the power of 1 plus cos theta. So this power will be written as a multiplying factor of 1 plus cos theta, and this power, its power, that is half, will be reduced by 1. So when 1 is subtracted from half, we get minus half, and in the next step we will convert this minus half into plus half by shifting this quantity from numerator to denominator. And as per rules of differentiation, we have also to differentiate the internal portion of the contained under this power minus 1 by 2. So we will differentiate 1 plus cos theta with respect to theta. We know that derivative of cos theta with respect to theta is minus sin theta. Okay, so our dy by d theta will become equal to minus sin theta over 2 1 plus cos theta square root or under root. What is this? This is dy by d theta, but we have to find simply dy differential. So dy will be equal to the same quantity into d theta, because d theta is here in the denominator, but then we will simply find dy. D theta will be shifted on other side of equality, and it will become as a multiplying factor. That is to say, it will be shifted from denominator to numerator. Number 17, y is equal to log. Here y is a function of theta, so we will differentiate y with respect to theta. Dy by d theta will be equal to d over d theta into log sin theta. We know that derivative of log x is 1 over x, and then d over dx into x, which is 1. However, if we have d over d theta into log u, then it will be 1 over u into du over d theta, but here that situation is not applicable. Okay, so dear students, we will get 1 over sin theta, and then derivative of sin theta, d over d theta sin theta. We know that derivative of sin theta is cos theta, and we know that cos theta over sin theta is a trigonometric identity which is equal to cot theta. So dy by d theta is equal to cot theta, but we have to find simply dy, that is differential. So dy will be equal to cot theta into d theta. Problem number 18, y is equal to ex over 1 minus e raised to power x. Okay, exponential function is in the numerator and also exponential function is in the denominator. Here y is a function of x, so we will find dy by dx. Dy by dx will be equal to d over dx into the whole function. Okay, here quotient rule will be applied. Quotient rule says that factor in the denominator is taken as a square, and then first we keep function in the denominator as constant and differentiate function in the numerator, then minus. We keep the function in the numerator as constant and differentiate function in the denominator. So dy by dx equal to d over dx, this becomes equal to 1 minus ex as it is, how then d over dx into e raised to power x. And we know that derivative of exponential function is always first the whole exponential function as it is, and then derivative of power of e with respect to x. So its derivative will be simply e raised to power x. Okay, minus ex into d over dx, 1 minus e raised to power x over 1 minus ex square as per formula of quotient rule. Okay, so we will get e raised to power x into 1 minus ex. Just we have written ex prior, previously it was written after 1 minus ex, but now we have written ex first and then 1 minus ex. Here d over dx of 1 will be 0 because 1 is a pure constant, and d over dx of minus e raised to power ex will be e raised to power ex. Okay, and this minus will become plus. Okay, so we will get e raised to power x into 1 minus ex plus e raised to power x into e raised to power x. Okay, minus will become plus over as it was previously 1 minus ex square. Now we open these terms. No, not open. We take common ex from upper two terms. So we will get ex within the bracket 1 minus ex plus ex. This minus ex will be cancelled with plus ex. So in the numerator we will get simply e raised to power x over 1 minus ex whole square. What is this? This is dy by dx, but we are going to find out dy differential. So dy will be equal to the same quantity into dx. So dy will be equal to ex over 1 minus ex whole square into dx. Okay, this is the end of our video. This is the end of our problems. Till next video, Allah Hafiz.